Welcome to Section 6, Networking Security and Encryption in Transit. In this section, we are going to cover different topics related to the security and the networking in AWS, like VPCs, public and private subnets, security groups and network ACLs, networking options like virtual private network, or private link, or direct connect, and also, of course, a very important topic like the different load balancers and other security solutions like WAF or Shield. CloudFront is more than just a security solution, but we are going to cover important topics about security with them. Let's start with VPC, public and private subnets. In this video, we are going to learn about networking and VPCs and subnet types. In a world where everything is connected, of course, networking is essential. So in AWS, we have net regions, availability zones, edge locations, VPCs, subnets, even your data center connected to all these components in AWS. So we have to think always how to have a fault-tolerant design or fault-tolerant architecture. Remember that in AWS, all data centers are online. So there are not cold data centers. So we can use the availability zones and regions always as based on our needs. All the services may have active or working in all the cases. So we have multiple layers services. So we can control the traffic flow not only using security groups, but also using ACLs. We will see what are the network ACLs also here during this section. All these connections can be also secure not only because adding multiple layers, but also adding encryption in transit. So SSL or TLS to protect against eavesdropping, tampering, message forgery. And remember, also in the initial years of AWS, we had only EC2 Classic, which was when you had instances exposed to the internet with a public IP. But since 2013, you can create VPC only EC2 instances or the scheme. They also call it like networking platforms. So EC2 VPC only is when you have a virtual private cloud where you place your EC2 instances. And it was available, as I said, since December 2013. In addition to that, all AWS services are protected against distributed denial of service, man-on-the-middle attacks, IP spoofing attacks. For example, also it's important to realize that ported scanning is not allowed by the AWS acceptance user policy. So that means that by the contract that you accept when you create your AWS account, you accept that you are not going to do ported scanning. Also, packet sniffing is not possible by other tenants for your virtual instance. So this is also important to take into account as well, with that the attacks like ARP cache positioning do not work within Amazon EC2 instances and also in VPC. You can understand how important is networking certification, networking knowledge in AWS, because, for example, AWS has released Specialty Exam. Actually, it's a specialty certification about networking. It's called AWS Certified Advanced Networking. Now let's talk about Amazon VPC. The virtual private cloud is your own network, isolated. It's a private network using also private IP addresses where you have the entire control. You need to have subnets. So you have an IP range inside the VPC where you put AWS resources. You may have public, private, and VPN only subnets. All the subnets assign IP addresses using DHCP, and also you can use DNS inside the subnets assigned from DHCP. Each subnet has to be in a particular availability zone. That means that VPC may be in more than just one availability zone. So a virtual private cloud, an isolated network, can be across multiple availability zones. We have network ACLs, NACLs, are access control list applied to subnets. So you control the traffic that is from and to subnet using NACLs. We will have a video specifically about network ACLs, and also we have routing tables, and that applies to the subnet to tell the hosts that we place in those subnets, where to go. If they go to one network or other network, where is the routing to follow. Internet gateway allow the VPC access to the internet. This is as easy as it sounds. Endpoints also enable private connection between your VPC and another AWS service, but also it can be your own service or third-party service. We will see that later. VPC peering is when you allow routing between two VPCs. So, for example, you have multiple VPCs and you want to make them talking each other. You need to create a peering between VPCs. Because remember, VPC is a private network. If you want to make two VPCs talking each other, the instances that are in the VPC to see each other to communicate, you have to create VPC peering. And finally, NAT gateway is a managed resource that allows you to connect your instances to the internet from your subnets, of course. So a NAT gateway it can be a managed service, but you can also create an EC2 instance working as a NAT to allow access to the internet, but it's easier and it's more recommended to use a NAT gateway for that matter. Subnets. So here in this diagram we can see region. In that region we have two availability zones, availability zone A and availability zone B, and two subnets, subnet 1 and subnet 2. As you can see, both of them are pointing to a router, but only the subnet 1 has the route to point the traffic to the internet gateway. As you see, from the subnet 2 to the subnet 1 and from subnet 1 to subnet 2, they are connected through the router because they have a routing table. But only subnet 1 instances are allowed to connect to the internet because they have the proper routing table. As you can see, IGWID 000, that means that they can access to the internet. And also, they have elastic IP addresses. So remember, a VPC network size can be from /16 to 28. A smallest subnet can be 28, so this is 16 IP addresses. But remember, the first 4 IP addresses and the last IP of every subnet, whatever the subnet size is, are reserved for AWS, for internal networking purposes. So for example, /28, we have only 11 IP addresses available. There are also a concept that is important to understand, which is the public IP addresses. When you launch an EC2 instance in a public subnet, and the public subnet is configured to assign public IPs, remember that this is a temporary public IP. Okay, so this is not going to skip if you restart, if you stop or terminate your instance. If you want to keep your IP address, you need to create an elastic IP and assign it to your instance. Here there is another example of VPC with different subnets, 2 private subnets and 2 public subnets with a load balancer. This is best practice, for example, because we are using our database tier and our application tier in multiple availability zones. When we talk about resilience and high availability, this is one of the best practices that we can use. VPC Flow Logs. When it comes to security and to troubleshooting, it's important to know that VPCs can show us the network information that goes through the different network elements that we have in a VPC. So we can enable VPC Flow Logs and capture the traffic, the network information from a VPC, a subnet, or a network interface. VPC and subnets, if you enable flow logs in a VPC and subnets, you enable logs for all the network interfaces in that particular VPC or subnet. And remember, each network interface has a unique log stream. We will see and capture later. All the logs are stored in CloudWatch logs, so we can access to the logs very easily using the AWS management console. The logs are not actually 100% real time, so we have to wait a little bit to see the traffic, but we can see actually the traffic. And you can also capture services more than your EC2 instance, but also the Elastic Load Balancer, RDS, Elastic Cache, Redshift, and Amazon Workspaces. What we see is we can also filter the traffic. If it's all the traffic, only the reject, only the accept. It's very helpful for troubleshooting. And also remember that you don't have to enable the entire VPC flow log. You can only enable what you need. For example, a particular instance or a particular service if you want to, or even just one subnet, the subnet that you want. But it's important to have it enabled because in case of an incident, you can look at the flow logs. So here is an example of a particular flow logs for one account in only one Elastic Network Interface, ENI, as you can see here. From where to where is going the traffic, we are seeing all the accept traffic for SSH. And here I wanted to share also with you a network diagram in AWS for a production environment. So we have multiple subnets for different purposes, like public subnet with the NAT gateway. We have application servers in autoscaling groups using their own security group. In an AWS diagram, when you see these red and black lanes, these are particular security groups, and also using S3, etc. So you may see different options on different diagrams, but it's important to understand that most of the production infrastructure in AWS, they share multiple availability zones, VPC net gateways, public and private subnets, etc. So let's see how AWS VPC works. So we are in the AWS Management Console. I can go here to VPC and I can start the VPC wizard to create the VPC. As you can see here, so we can create VPCs using the API, of course, or the command line interface. But here we have different options in this wizard. So VPC with public and private subnets, VPC with public and private subnets and hardware VPN access, or even a VPC with a private subnet and having only access for a VPN access, hardware VPN access. As you can see here, this is probably the most secure or most isolated implementation. So if you have this implementation, there is no way to access to this VPC unless you have the VPN connection from your corporate data center. So this is why we set a virtual private cloud. It's totally 100% private unless you configure it to do something different. So let's create a VPC with a public and private subnets like here in this diagram. We can set app2. For example, this VPC is going to be called app2 VPC. The default networking. So the availability zone, we can choose availability zone. If we don't choose availability zone, it's going to choose the first one. And there's also the private subnet. So as you can see here, public and private subnet with different CIDR. In this case, /24. And it says, as I mentioned before, 251 IP addresses available. And the Elastic IP allocation ID that I'm going to use for the NAT gateway. Remember, the NAT gateway is going to be the device that allows our instances to access to the internet when they are in a subnet. So that NAT gateway requires a public IP, and I need a public IP allocation first. This is something that I had to create beforehand. If I want to create an endpoint like an S3 bucket or etc., I can add it here. We will learn more about endpoints later. And if we want to enable host names and even hardware tenancy, for some regulations or compliance, we may need a dedicated hardware to run our instances, so we can choose it here, but we are going to leave it default. So here is our new VPC. We can see this CIDR block associated and flow logs. What I recommend you is to enable flow logs for everything, at least to learn how it works, and then you can control what you want to filter, etc. So I want to filter here, in this case, everything. The role I'm going to use is going to be the flow logs role. If you don't have flow logs role, you have to create it. Clicking here in set permissions. And the destination group is going to be flow logs. If you don't have the destination log group, you can type it and it's going to be created automatically. So we can create the flow logs. So now if I go here to CloudFormation logs group in CloudWatch logs, I can see actually one of the first log streams. This is the network interface. There is no data and it's just starting. Okay, so let's go back to the VPC. So here we have different actions like edit DNS resolution if we want to allow it, the DNS host name, DHCP options, etc. Let's go back to the presentation. So remember, as a best practices, we need to control the different options in the networks. Throughout this section, we also learn about firewall, security groups, etc. So that we can control the network traffic in the VPC using different options, and also around the VPC, like using AWS WAF, or even inside the host using host-based firewalls, etc. So we will learn a little bit more about these concepts, but I think it's important to understand at least what is a VPC and how it works. So as a summary, now we know networking regarding AWS, VPCs, subnet types, and how to create VPCs.